Sonar is an example of a use of ultrasound. State one other example of a use of ultrasound. It's quite easy. You can go for fetal scans, dog whistles, treating kidney stones, lots of reasons. State one example of a use of infrasound. So infrasound are frequencies below 20 hertz, whereas ultrasound are above 20,000 hertz, so just above and below our hearing range. So we can use infrasound to study Earth's structure, seismic activity, animal communication. Large animals communicate using infrasound, such as elephants. Figure 1 shows the depth of the sea measured using sonar at different distances from the shore. So you can see here we're getting further away from the shore, and here's the depth of the sea at different distances. So it's quite an easy graph to understand. A technician on a boat uses sonar pulses to measure the depth of the sea when the boat is 120 meters from the shore, so when it's over here. Calculate the total time of travel for the sonar pulse used to make this measurement. The speed of the sonar pulse in seawater is 1600 meters per second. So firstly, we need to choose an appropriate formula, and this question's for 4 marks. There's quite a lot of things to do here. So if we look, we've got time, speed, and distance. Those are the figures. Those are the measurements. So we should be able to pick a formula quite easily, which would be speed equals distance divided by time. Those are the values we've got, and that's the most appropriate formula. But here we're asked to calculate total time. So the first thing we need to do is rearrange this equation. Distance, by the way, is the depth of the sea, how far the pulse had to travel. And we work that out from the graph. So we go to 120 meters and then basically extrapolate from there. So yeah, we have distance and we have speed, but we need to work out time. So here's how we can rearrange the equation. If we go here, what I've done here, and this is a really good technique, is I've applied values to the equation, which makes sense. So I always use the values for 3-part equations. I use 6, 3, and 2, and I assign them to the various characters or the formula letters in a way that makes sense. So if distance was 6 and time was 3, then speed would be 2, because 6 divided by 3 is 2. But I want to work out time. So how could I rearrange this to make sense? Well, time is 3. What can I do to 6 and 2 to make 3? So if I divide 6 by 2, I get 3. And that makes sense. So time equals distance divided by speed. So you get 1 mark for rearranging. However, the question, if you remember, said total time. And it's written total in bold, so there's a reason why it said total time. So if you look here, what we've got here is the time it takes for the pulse to go to the bottom of the sea, how long it takes for it to travel to that depth of seawater. But what we're trying to work out is the time it takes for it to go there and back. So what we have to do here is acknowledge the distance the sound travels is twice as long as it initially seems. So we now have to change our formula to this. Distance times 2 divided by speed will give you total time, because then it will be there and back. So now I just substitute in my figures. So I've got my 14, which is my distance as worked out from this graph, times 2, which will be 28, and divide that by 1600, which we were given here as the speed of the sonar pulse. So if we do that, we get 0.018 seconds, and I've done it to 2 significant figures here. So that will get you all marks.